Hi, and welcome to this session on Introduction to Generative AI. Do not know what that is? Then you are in the perfect place. I am Raghvendra Sharma, Senior Programming Officer at ONGC. Today, we will explore how AI has evolved from analyzing information to actually creating it. In this course, I will teach you four things. We'll start by defining what generative AI really means. Then we will look at how it works. After that, I will describe generative AI model types and generative AI applications. But let's not get swept away with all that yet. Let's start from the very basics. The meaning of generative AI. Generative AI is a type of artificial intelligence that can create new content including text, images, audio, or even synthetic data, unlike traditional AI, which focuses on analyzing data and finding patterns. But what is artificial intelligence? Since we are going to explore generative artificial intelligence, let's provide a bit of context of artificial intelligence. Two very common questions asked are, what is artificial intelligence and what is the difference between AI and machine learning? AI is a branch of computer science that deals with the creation of intelligent agents and are systems that can reason, learn and act autonomously. There are two main types of AI. First one is narrow AI. Narrow AI is built for a specific task like ChatGPT, Siri, or an image generator. And another is general AI. General AI is still a theoretical concept. It is defined as a system that can perform any intellectual task a human can. Now let's talk about machine learning. Machine learning is a field of artificial intelligence. It involves using algorithms that learn a pattern from input data to train a model. Once trained, the model can make predictions or decisions on new that is unseen data drawn from the same type of distribution as the training data. This means machine learning gives computers the ability to learn and improve automatically without being explicitly programmed for every task. So what do these machine learning models look like? Two of the most common classes of machine learning models are unsupervised machine learning and supervised machine learning. Let's delve into more. In supervised learning, we train models using labeled data, meaning we already know the correct answers during the training. That means the learning system is given inputs and told which specific outputs should be associated with them. The model learns from these examples to predict outcomes in future unseen data. On the other hand, in unsupervised learning, there are no labels. Unsupervised problems are all about discovery, about looking at the raw data and seeing if it naturally falls into groups. The algorithm explores the data to find hidden structures or grouping on its own. Let us understand this with an example. Like in our office or in any working place, we can cluster employees by behavior or customer segments or any other features. Say we can collect the data, how much time do they take break, and then by analyzing similarities we can find the pattern between the employees taking breaks. We can find some data like who are the employees who are going together, who are employees who will take break after that particular person has taken break, so we can find a pattern. So now to understand more, let us also explore another important ML model, that is reinforcement learning. Reinforcement learning is a different approach. Here, an agent learns by interacting with an environment. It takes an action and receives feedback in the form of rewards or penalties and gradually improves the strategy. So imagine teaching a dog to sit. Each time the dog sits, when you say sit, you give it a treat. that is reward. If it does not, it gets no treat. Over the time, the dog learns that sitting when told leads to something good. That's reinforcement learning in action, learning by reward and consequences. Another great example is a self driving car, learning to navigate through trial and feedback. It is like learning from experience, one decision at a time. So, before diving deep into Gen AI, let us first understand artificial neural networks. Neural networks is the backbone of modern AI. Artificial neural network or neural network are inspired by the human brain. Like your brain, they are made up of many interconnected nodes or neurons that can learn to perform tasks by processing data and making predictions. Neural network can use both labeled and unlabeled data. That means these neural networks can be trained on supervised or unsupervised machine learning models. Let us understand the neural networks step by step. The first part is the input layer. This is where the data enters the network. For example, if we are giving an image to the computer, each pixel of that image becomes a number that goes into the input layer. Each input is then multiplied by something called a weight. This weight tells you the system how important that particular input is. Imagine if you are entering image of a cat or a dog or say a car. So each pixel, if it is representing say ear, then it is more important than the pixel which are representing the background of the image. So accordingly the weight is adjusted. All these weighted input are added together. We call this the pre-activation step. The combined result then goes through an activation function which decides whether that artificial neuron should activate or not. You can think of this like the neuron in our brain firing only when it gets enough stimulation. Now, in a simple or single neural network, this process happens just once, the pre-activation and then activation function, from input directly to output. But in more advanced systems, there are multiple hidden layers between the input and output. Each of these layers learns something different. The first layer might detect, for example, simple pattern like lines or edges. The next might recognize shapes, and the deeper layers could identify entire objects like a cat, a car, or a face, as I told earlier. Finally, all these processed information reaches the output layer, which gives the final result. For instance, it might predict this image is a cat or car or whatever it is. So far, we have explored the differences between artificial intelligence and machine learning. We have also learned supervised, unsupervised, and reinforcement learning. So, now let us talk more about artificial neural networks. So, when the neural networks becomes deeper and more complex, that means the hidden layer consists of multiple layers. We get deep learning. Since deep learning consists of a neural network of multiple layers, it enables machine to handle tasks that once required human intuitions, like understanding language or generating art. It is actually the deep learning revolution that paved the way for generative AI. Deep learning models or machine learning models in general can be divided into two types: generative and discriminative. Discriminative models are trained to classify or predict outcomes like deciding whether an image is of a cat or a dog, whether this email is a spam or not. Basically, those discriminative models are trained on label data, so they can basically work on differentiating between this or that. Generative models, on the other hand, create new data. They imagine what new cats or dogs could look like based on what they have learned and that prompt they have been given. Generative models are all about creation. They can generate new data samples, synthesize complex patterns, and produce content across text, visuals, or code. Like when an image of a dog or cat or a car is passed to a model, it can generate a new image of a dog that may never have existed. Examples include ChatGPT for text, DALL-E and Midjourney for creation of images, and GitHub Copilot for code. These systems do not just retrieve data, they generate new ideas from what they have learned. Discriminative models work differently. A discriminative model is a type of model that is used to classify or predict labels for data points. For instance, a discriminative model can look at a picture and say this is a dog, not a cat. They are great for tasks where we already have labeled examples. Let us understand the foundation models of generative AI. The generative AI process can take training code, label data, and unlabeled data of all data type and build a foundation model. The foundation model can then generate new content. These are the large-scale systems that power most of today's AI tools. These models are pre-trained on vast amounts of data like text, images, audio, and then fine tuned for a specific purpose like some image creator or some human type language generator. They can be fine tuned for a specific task. They come in three main forms. The first one is language model for text and chat generation, and then vision models for image recognition and creation, and multimodal that combine text, visuals, and sound to perform complex tasks. For example, models like Gemini, Google's multimodal AI model, or Lambda language model for dialogue applications ingest very large data from multiple sources across the internet and build foundation language models we can use simply by asking a question, whether typing it into a prompt or verbally talking into the prompt itself or providing some other context. Among foundation models, large language models or LLMs that are called in short have had a biggest impact. So these models are trained on billions of words, allowing them to understand and generate natural human language. They are capable of writing, reasoning, summarizing, and even explaining concepts clearly just like humans do. For example, translating from one language to others. LLMs are built on a transformer architecture and can contain hundreds of billions of parameters. For example, GPT-3 has 175 billion parameters, while GPT-4 surpasses 1 trillion. This is the difference in size. That's how GPT-3 and GPT-4 has the difference. This scale allows them to grasp context, intent, and nuance like never before. So the size of the parameter decides how accurate and how good the model is going to perform. So well-known LLMs include OpenAI's GPT series, Google's Bard, Meta's Llama, and Anthropic's Claude model. These are the very popular and we are using. So far, we have understood large language models, say LLM. Now we see their use cases. LLMs have transformed the way we work. They power chatbots and conversational AI like ChatGPT and Bard, providing natural dialogue in customer service or education. They generate blogs, reports, and marketing content in seconds. Developers use tools like GitHub Copilot to write and debug code faster. They summarize complex documents, assist in research, and even personalize learning for students. Now we come back to generative AI. Till now we were focusing on foundation model of generative AI. So beyond text, generative AI is driving innovation across industries. It helps in code generation, translating and debugging across programming languages. It powers intelligent chatbots and virtual assistants for both customers and employees. It automates content creation, summarization, and translation, and performs sentiment analysis to gauge public opinion. It even enables custom search experiences tailored to specific needs, The possibilities are almost limitless. So now we have learned everything theoretical about generative AI. So to wrap up, generative AI marks a major shift in the field of artificial intelligence. It bridges logic with creativity, enabling machines not just to analyze but to imagine. As we continue exploring this technology, one thing is certain, that generative AI is going to rule forever. Thank you for joining me in this session on generative artificial intelligence.